On this slide, I'm going to work some examples of calculations involving the definition of molarity. That's a concentration unit. When we have the moles of the solute, that would be the compound, and that's going to be divided by the total liters, which is the entire solution. So algebraically, we can write that as M equals N over V. And the examples I'm going to use are from the practice worksheets that are on the S drive or on Angel. So I'm going to work number 1, and here we are asked to find the molarity of a solution. So if we're trying to find the molarity, that means we need capital M. So that means we need moles in the numerator and liters in the denominator. So this problem gives us the moles, 0.566 moles, and it gave us the solution volume as 250 milliliters. So I'm just going to rewrite that here. So question 1, molarity equals, again the moles were given, 0.566 moles, and our volume that was given is 250 milliliters. The volume needs to be in liters, so we'll convert 250 milliliters to liters by moving the decimal 3 places to the left. And then our units there, capital M is a mole per liter, and so all we have to do now is do that division. 0.566 divided by 0.25, and we get 2.264. If we use 3 significant figures, because this 250 has a decimal place, so we'll round this answer to 2.26, and we would rewrite the capital M. So we solve for capital M with moles in the numerator and liters in the denominator. The next problem I'm going to work is the most common, and that is when we're looking for moles. So in this case, number 7 on the practice worksheets, we are asked for how many moles of NH3, that's the solute, would be in a solution that's 1.5 molar, and the volume is 25 milliliters. So we have a V, and again we have an M. So if we're given a volume and a molarity, we're going to multiply those to solve for moles. So problem number 7, let me put that here. Problem number 7, we are asked to calculate N. So if we rearrange this equation to solve for moles, N equals M times V. And the M that we're given is 1.50. So 1.50, instead of writing M, I'm going to write moles per 1 liter, because that's exactly what capital M means. And again, this was given to us in the problem. We had that value was given. And then if I multiply that by the 25 milliliters, so our volume is normally going to be in milliliters, so we've got to convert 25 milliliters to liters. So if we write down 25 milliliters, move the decimal 3 places to the left, that is going to be molarity, capital M, which has 2 units, times volume, so the liters cancel, and 1.5 times 0.025 gives us 0.0375, and that would be moles of NH3. So again, solving for moles is the most common use when we're given a molarity and a volume. The next problem I'm going to work is going to ask us to calculate a mass. So if I look at question number 10 on the practice worksheets, we're asked for how many grams of potassium hydroxide would we need if we wanted to make 400 milliliters of a solution, and we wanted that solution's concentration to be 0.300 molar. So if we're looking for mass, the first thing we're still going to need to do, because we're given a volume and a capital M, we're going to multiply those together to solve for moles of KOH. And once we have moles of KOH, we can get out the periodic table and find the molar mass to convert to grams. So if I rewrite question 10 here, we're looking for mass of KOH, and we are given that our volume is 400 milliliters, and we want the solution to be 0.300 molar. And so remember, this capital M has 2 units built in. I'm going to actually take the volume and multiply by the concentration. We could take the concentration and multiply by the volume, but if we start with the volume, convert that to liters, so 400 milliliters is 0.400 liters. Then when I write my concentration unit, that capital M, the 2 units are going to show up here as a conversion factor. So this is 0.300. Capital M means moles per 1 liter. Our liters cancel. So at this point, we could calculate how many moles of KOH we have. And if we read the problem, we're looking for the mass. So I'm going to get out the periodic table. And the molar mass, remember this is the big fat 1. 1 mole of KOH weighs what 1 potassium weighs, plus 1 oxygen, plus 1 hydrogen. And potassium weighs 39.1, plus oxygen weighs 16, plus hydrogen weighs 1.008. So if I add those values together, then I'm going to get 56.108. So that's the mass in grams of 1 mole of KOH. And this number is already in the calculator, so I'm going to multiply by 0.3 and then multiply by 0.4. And I get 6.73, that's what we'll call that. So this is the way we would make a solution. You might not want a liter, maybe we only want 400 milliliters of a solution, and the recipe calls for a 0.300 molar solution. So we're going to have to make it by weighing out 6.73 grams of potassium hydroxide. Then we would put that in a volumetric flask that is used to make a 400 milliliter solution and fill it up to the mark with water. So we've used this definition in question 1. We solved for molarity. The problem would have to give us the numerator and the denominator. In question 7, we solved for moles. So then we rearrange this equation and take molarity times volume to get to moles. And in the next question, we still used molarity M times the volume. That right there would allow us to calculate moles, but if we're asked to calculate mass, we just add one more step and do the molar mass to convert from grams to moles. The last problem I'm going to work, we're going to be looking for volume. So I'm going to work problem 4. And we're asked what volume we would need if we wanted a 1.5 molar solution to contain 0.5 moles. So it really doesn't matter what the formula is. So we're solving for V. The problem gives us an M and the mole, which would be the N. So if we're solving for V, I'm working problem number 4, V equals question mark. So if we're looking for volume, this is really the best formula to remember. If I want to solve for volume, I'm going to divide both sides by m. And in question 4, we're told that the moles that we want 0.5 moles, and our capital M is 1.5. So we're going to take 0.500 moles and divide by 1.50. Capital M is still a mole per liter. So the moles cancel, and our volume unit is actually the denominator of a denominator, which turns into a numerator. If we take 0.5 and divide it by 1.5, we're going to get 0.33333. So this would be 0.333 liters. And if we were making this in the lab, we would probably convert that back to milliliters. So 333 milliliters of a 1.5 molar solution would be the amount required so that we had 0.5 moles.